Okay, guys, today is going to be Tuesday, November 7th, 2023, and I'm making this video for you based on the worksheet that we just did in class. So I'm going to break it down for you and tell you how you get the answers on 1 through 20. So I don't anticipate this being a very long video, but it should be hopefully be very helpful. Okay, so the name of the worksheet is naming compounds. And there's 20 problems. I'm just going to get started, okay? Number 1 is CaF2. Both of these are monatomic ions. That's calcium. That's fluoride. So the name is calcium fluoride. Oop. And now, by the way, both of these are monatomic ions. Now, calcium has a positive 2 charge. Fluoride has a negative 1 charge. So you need 2 of them to equal a negative 2 charge. That's why it's that ratio of 1 to 2. Next, NaF. Na is sodium, and F is fluoride. Sodium fluoride is the name of the compound. Now, as far as why it's NaF, a 1-to-1 ratio, sodium has a positive 1 charge, fluoride has a negative 1 charge. They balance out at a ratio of 1 to 1. Sodium is in group 1, fluoride is in group 17. Number 3, aluminum fluoride, AlF3. Aluminum fluoride. Aluminum has a positive 3 charge. It is found in group 13. Fluoride has a negative 1 charge. So you're going to need 3 of those to get to negative 3. So positive 3, negative 3 cancel out. That's why this is a 1 to 3 ratio. All right, now we step it up a little bit more. Number 4 is SrF2. This is going to be strontium fluoride. Strontium is in group 2, so it has a positive 2 charge. Fluoride is in group 1, it has a negative 1 charge. Now there are you got positive 2 to negative 1, so you need to have 2 fluorides to equal a negative 2 charge. Negative 2 cancels out positive 2. That's why this is a 1 to 2 ratio. Okay, number 5, Ag3N. All right. Now, for our purposes here, I'm not going to tell you the very specific rule in silver. I just want you to apply the overall rule here. Silver is a transition metal. You don't know what its charge could be. It's in the D block. But what you do know is you have nitrogen. Nitrogen is in group 15. It has a negative 3 charge. You only have 1 nitrogen. It technically is now nitride. So you have 3 silvers here. So here's my question. What times 3, that 3 right there, would equal positive 3? The answer is positive 1. So that 1 is what you're going to call silver. This is going to be called silver 1 nitride. This 1 is indicative of that charge. So you have 1 silver here, 1 silver here, 1 silver here. 1 plus 1 plus 1 is going to be positive 3. And then you have this 1 nitrogen, which is negative 3. Positive 3, negative 3. They cancel each other out in a 3-to-1 ratio. Okay. Number 6. Pb3, P2. Now, listen very carefully. Lead is in group, it's in the P group, in the P block. It's in group 6, but it is a metal. And so it is a transition metal. Now, as we get further down the year, you guys are going to learn that lead can have 2 types of charges. Lead can either be positive 2 or it can be positive 4. How do you know which one to use? I think that there's a student, I'm not going to say his name, said you guess. You don't guess. You look at the anion. That's phosphorus. And it has a negative 3 charge. Now, there are 2 phosphoruses, so negative 2 times 3 is negative 6. All right? So here's my question for you all. What times 3 would equal positive 6? And the answer to that is positive 2. Each lead has a positive 2 charge. So here's how it looks if you expand it. Lead 2, lead 2, lead 2, positive 2 plus positive 2 plus positive 2 is positive 6. Then you have 2 phosphides, negative 3 charge, negative 3 charge. It's going to be negative 6. They cancel each other out. So this is going to be, oh, I didn't even, yeah, I did. This is going to be called lead 2 phosphide. It's 2 because each lead has a positive 2 charge. Here, here, here. Number 7, FeBr3. Now, iron, we all know that Fe is iron. That is a transition metal. You don't know what its charge is. It could be positive 2. It could be positive 3. So what you do is you look at your anion. That's bromine, or now bromide. And bromide has a negative 1 charge. There are 3 of them. So negative 1 times 3 is negative 3. You have 1 iron here. So what must iron's charge be to balance out that negative 3 from the 3 bromides? It should be positive 3. So now you're going to have iron 3 bromide. Number 8, CuBr. Copper is Cu. It's a transition metal, so you can't deal with that first. You're going to have to look at bromide first. Bromide has a negative 1 charge, and there's just 1 bromide. So what must the charge of this 1 copper be to balance that out? Positive 1. So the name of this is going to be copper 1 bromide. And I'm going to remind you, before I go any further, that you don't use Roman numerals on elements that are in groups 1, 2, 13, 14, 15, 16, 17, but mainly you don't use it. You only really use them on cations, but not on cations that are not in the D block. With one exception, you know, like lead is one of those exceptions that does need Roman numerals. Number 9, Mn. S. Now, Mn is manganese, not magnesium. Manganese is element. Let me look at my giant periodic table in my room. Let me see if I can find it. Where is it? There it is. It's element 25. It's in the D block. So you've got to come back to that. Look at sulfur. Well, now it's sulfide. It's in group 16. It has a negative 2 charge. And there's only 1 sulfide. Negative 2. So what must the charge of that manganese be to balance it out? Positive 2. So we're going to have manganese 2 sulfide. So to reiterate, repetition is good. You only use Roman numerals on elements that are in the D block with just a few exceptions like lead. Speaking of which, number 10, PbO. Looks like we have 1 of each. Lead is one of those exceptions. It is in the P block, but it is a metal, so you need to go to oxygen first. It is now oxide. It's in group 16. It has a negative 2 charge. There's only 1 oxide. So what must the charge of the lead be to balance that out? Positive 2. And so the name of this compound is lead 2 oxide. And we're halfway there. Number 11, FeBrO3, 3. Okay, now take a breath before you go any further. BrO3 is a polyatomic ion that I told you you do not need to memorize, so I will tell you its name. Its name is bromate. It is on your list. So if you look up BrO3, you will find that it has a negative 1 charge. There are 3 of them. So negative 1 times 3 is negative 3. Take a look at iron. There's just 1 iron. So what must that iron's charge be in order to cancel out the negative 3 from the 3 bromates? It must be positive 3. And so we're going to call it iron 3 bromate. Number 12, Li3PO4. Okay, now we're dealing with monatomic ions and polyatomic ions. Lithium is in group 1, so you do not need Roman numerals. So just write lithium, and you all should know the polyatomic ion PO4, that is phosphate. But what I want to teach you now is, and you don't need Roman numerals for elements in group 1 or 2 or like aluminum and so on. But I do want you to see why it's in this 3-to-1 ratio. Lithium has a +1 charge. Phosphate has a -3 charge. You need 3 lithiums to balance them out. That's why it's Li3PO4. Number 13, we have CuCH3COO. All right. Now, if you've been studying, you know your stuff, you'll know that all of this is acetate. That's called acetate. It is one of the 8 that you must memorize. It has a -1 charge. And if I look at it, I don't see any multiples, so it's just that one, -1 charge. So what must the charge of this copper be to balance it out? It must be +1. So it's going to be called copper 1 acetate. If you're wondering why did I not use a Roman numeral on lithium, but I did on copper, lithium is in group 1. That's the S block. You don't need Roman numerals for those because its charge is 1 and only 1. It's +1. But copper could be +1. It could be +2. So you have to indicate which one it is by the Roman numeral because it is a transition metal. And the transition metals must be identified with Roman numerals to indicate their specific charge. Number 14, we have BaCO3. Okay, CO3 is a polyatomic ion you guys memorized. That is carbonate. I'll write it out over here. That is one of your 8. And if you've been studying, you'll know that it has a -2 charge. Notice that there's only one carbonate, CO3. That is carbonate. So you should also know that barium is in group 2. You don't need to guess. It is a +2 charge. And so they cancel each other out in a 1-to-1 ratio. So it's just going to be barium. No Roman numerals needed because barium is in group 2. It is not a transition metal. Number 15, CdOH2. All right. Cd is cadmium, and I believe that is a transition metal. Let me just kind of look around, trying to find it on my periodic table. There it is. It's in group 12, so it's definitely transition. So you have to write Roman numerals. So you need to look at this. If you've been doing your studying, you will know that OH is hydroxide. That is one of the 8 you must memorize, a polyatomic ion, and it has a -1 charge. I see that there are 2 of them. And so -1 times 2 is -2. So what must the charge of that one cadmium be to balance it out? It must be +2. And so you're going to write cadmium, Roman numeral 2, and then close the parentheses, cadmium 2 hydroxide. 5 more to go. Number 16, PbCH3COO4. Okay. Lead is variable. You don't know if it's lead 2 or lead 4. So we will come back to that. But I do know, you just had this a couple problems ago, that this is acetate. So I'll go ahead and write it down. That is one of the 8 you must memorize. And acetate by itself has a -1 charge. I see that there are 4 of them. So -1 times 4 is -4. Lead is all by itself. So what must the charge of lead be to balance out this +4 from the 4 acetates? Or the -4 from the 4 acetates. Sorry if I said positive. And that should be +4. So this is going to be called lead, Roman numeral 4, that's IV, acetate. Number 17. NH4 SO3. Okay. This one's kind of funny because SO3 is a polyatomic ion. NH4 is a polyatomic ion. Oops, I didn't write it right. Let me fix that. There we go. You guys just learned that today, November 7th, 2023, and how to name this. But I did tell you you can look at your list. You do not need to guess any charges here. There is no Roman numerals here because they're both polyatomic ions. So I can just take them one at a time. This is ammonium. That is one of the 8 that you must memorize. And ammonium has a +1 charge. You can see that there are 2 of them. So +1 times 2 is +2. And this is sulfite. Now, yes and no, you should know this. No, you don't have to memorize sulfite. But as I taught you in class, if you have something like SO4, which you do have to memorize, and that's called sulfate, 1 less oxygen would make it sulfite. So yes and no, you should know its name. And notice that it has a -2 charge. So that's how they balance each other out at a 2-to-1 ratio. 3 more to go. Number 18, CdCO2. Okay, this one seems a little tricky. Now, CO2 is something that you did not have to memorize, but it's the same sort of situation with 17. You guys do have to know CO3 with a -2 charge. That's called carbonate. So if I take 1 oxygen away and make it CO2 with a -2 charge, that's called carbonite. And so this guy is carbonite. And notice up here, it has a -2 charge. There's only 1 carbonite. So what must the charge of this cadmium be in order to balance it out? That would be +2. And cadmium is a transition metal, so you must use Roman numerals. Cadmium 2 carbonite. Number 19 is going to be 2 polyatomic ions, NH4, 3 PO4. Both of these you must memorize. The name is pretty straightforward. Ammonium phosphate. You have to know both of those. Now I just want to show you why they are in a 3-to-1 ratio. Ammonium has a +1 charge. Phosphate has a -3 charge. Those by themselves do not equal out. They do not equal 0. And so you need to have 3 ammoniums. +1 times 3 is going to be +3. That will balance out the phosphate's -3. And then you're going to have that 3-to-1 ratio. And then the last one, number 20, CrCl6. Okay. Cr is chromium. It is a transition metal. It is number 24. You have to have a Roman numeral for it, but you don't know which one. So you look at chloride. Chloride has a -1 charge. It is in group 17. That's how I know that. There are 6 of them. So -1 times 6 is -6. So what must the charge of that 1 chromium be to balance out the charge for the chlorides, the 6 of them? That should be +6. So the name should be chromium, Roman numeral 6, chloride. Okay, that is all 20. If you look this over and you still have any questions, you know how to contact me. Good luck studying.